Welcome to the video on stationary points. In this video I'm going to be explaining the basics of stationary points and using an example that was posed to me by one of my viewers to explain how we can find the coordinates of stationary points and also determine their nature. So let me first go over the basics of what a stationary point is. If I draw this arbitrary curve, if we look at this curve in several different places, we can say that here, for example, the gradient is high, as it is here. But if we get closer and closer to these flat points on the curve, we can eventually say that here, the gradient, or dy dx, is 0. Similarly up here, and basically a stationary point is just defined as any point on a curve where the gradient, or dy dx, is equal to 0. And the nature of a stationary point is either a minimum or a maximum, or at least they're going to be the two types we're looking at today. So if you were to have a glance at this graph, you would probably intuitively guess that this one here was a maximum whilst this was a minimum, and you'd be correct. But the way this is technically defined is by the rate of change of the gradient itself, which is denoted by d2y by dx squared. So here, the rate of change of gradient is negative, because the gradient's getting ever less until it becomes negative at that point. So we can say that there, the rate of change of gradient, or d2y by dx squared, is less than 0. And if that is the case, then the point is a maximum. So we can just write max. Conversely, at this stationary point, you can see the rate of change of the gradient is increasing, since here it is negative whilst past the stationary point it becomes positive. So that would be d2y by dx squared is greater than 0. And whenever this is the case, it is a minimum point. So they're the basics of what we have to know before we tackle this problem. Okay. Now the equation we've been given is y equals x cubed over 3 minus x squared over 2 minus 2x. Now firstly, as we've just discussed, we need to be able to set the gradient function, or dy dx, to equal 0. So initially we have to differentiate. And write dy dx equals, and then just differentiate as we have done previously. So that will become 3x squared over 3, which just cancels down as x squared. Similarly, that will become 2x over 2, which cancels to x, and then this just becomes 2. So we know now to set this to 0, since dy dx must be 0 at any stationary point. And then we become left with a fairly simple quadratic equation. Now our first instinct here should be to factorise, and that would be correct. And then from here we should be able to solve for x fairly easily. So we can just jot down that x equals 2 and minus 1. So this, or these two coordinates, are the x coordinates of all the stationary points found on that curve. So now we need to find the corresponding y coordinates to each of these. And we can do that by subbing in this x value into our initial equation, because that's just the equation of the curve. So we can do this just over here. So when x equals 2, 2 cubed over 3 is 8 over 3 minus 4 over 2 cancels down to 2. And that becomes minus 2 times 2 minus 4. And then that simplifies to minus 10 over 3. And then when x equals to minus 1, we have minus a third minus a half plus 2. This simplifies to 7 over 6. So we found the y coordinate, you can just jot that down, and each corresponding x coordinate. So we can jot down the full coordinates of our stationary points. And that would just look like this. So that's half the problem done already. We've got full sets of coordinates for both stationary points on the curve. Now to determine the nature of those stationary points, we'll just put the x coordinates down because we'll be needing them later. We know that we need to find the rate of change of the gradient, which is d2y dx squared, and just the derivative of dy dx. So we can just do this. And then just differentiate normally, so this becomes 2x, this becomes 1, and then you omit the constant as normal. And so now it's as simple as subbing in our x coordinates for our stationary points to this equation here, which is just our rate of change of gradient, to find out what value we have for the rate of change of gradient at the coordinates of each stationary point. So if we start when x is 2, we just get 2 times 2 minus 1, and that is equal to 3. And since 3 is greater than 0, you can say therefore it is a minimum point, as we discussed at the start with the drawing of the arbitrary graph. Then if x equals minus 1, we get 2 times minus 1 equals minus 3, which is obviously less than 0. And as we said again, except conversely this time, this makes it a maximum point. Since the rate of change of gradient is ever decreasing, it must mean that that stationary point is a local maximum. So we've solved the problem, we've found all the information that we need, and we've covered the basics of stationary points. Thank you for watching.